Here are a few questions from the paper Quantum Mechanics. You may see them one by one. See the first question. Define a linear harmonic oscillator. When a system vibrates about an equilibrium position in such a way that the force acting on it is directly proportional to the displacement from the equilibrium position, and the direction of the restoring force is opposite to that of the displacement, it is called a linear harmonic oscillator. Mathematically, we can write force is directly proportional to displacement and F is equal to minus kx. Here, negative sign implies that the restoring force is acting in a direction opposite to that of the displacement. See the second question. What are the examples of harmonic oscillator? A simple pendulum, an object floating in a liquid, a diatomic molecule, and an atom in a crystal lattice are examples of harmonic oscillators. Give the potential energy of linear harmonic oscillator. V equal to half kx square is the potential energy of linear harmonic oscillator. According to the definition, F is equal to minus kx, but gradient of negative potential is called force. Minus dV by dx is force. From these two equations, dV by dx equal to kx, then dV equal to kx into dx. Then if you integrate, integral dV equal to k into integral of x dx, varying from 0 to x, then we can get v equal to half k x square. Integral of x dx is x square by 2. Therefore, we can get this result. Write down a linear harmonic oscillator's one-dimensional energy equation. En is equal to n plus half h cross omega is the energy expression. If you put n is equal to 0, we can get our 0 point energy. It is half h cross omega. If you put n is equal to 1, we can get our first excited state 3 by 2 h cross omega. Or n is equal to 2, we can get 5 by 2 h cross omega. In the case of linear harmonic oscillator, the energy levels are equally spaced. The difference between any two successive energy levels is 1 unit of h cross omega. What is 0 point energy? If you put n is equal to 0 here, then we may get E0 equal to half h cross omega. The system is having some amount of energy, even though the value of n is equal to 0 is called 0 point energy. Write the general and the normalized wave function of a harmonic oscillator. Sin of x equal to n into e power minus q square by 2. The hn of q is the wave function of linear harmonic oscillator. Here n is the normalization constant. Its value is evaluated using the normalization condition. Sin star of x, sin of x dx equal to 1. If you make the integration, you can get the value of the normalization constant n suffix n is equal to alpha divided by 2 power n factor to the root pi. Entire is present inside the root. If you substitute this value here, you can get our normalized eigenfunction. Find the expectation value of potential energy of linear harmonic oscillator. For the expectation value, we have to use the formula psi star, then operator value psi into dx. If the wave function is normalized, we know the value of potential, that is half kx square, but k by m is equal to omega square, k equal to m omega square. Substitute here. Then we may get half m omega square integral psi star x square psi into dx. This is our expectation of x square. Expectation value of x square is n plus half into h cross divided by m omega. If we substitute this, we can get half n plus half h cross omega is the expectation value of the potential energy. This is half of the energy eigenvalue of linear harmonic oscillator. Give the value of Hermite polynomial. Hn of q equal to minus 1 power n e power q square d power n divided by dq power n into e power minus q square is the value of Hermite polynomial. What's the value of ground state wave function of a linear harmonic oscillator? If you put n equal to 0 in this wave function, we may get our psi 1 of x, that is ground state wave function. That is 2 alpha divided by root pi power half e power minus q square. Here ground state is represented by psi 0. N is equal to 0. This is our left ground state wave function. See the next question. What is a potential barrier? When a particle approaches a region in which the entrance of the particle is opposed by some force, then the region is said to form a barrier. What is tunnel effect? If a particle with energy less than the height of the barrier crosses the barrier, then this phenomena is called tunnel effect. See, the barrier height is V0. Suppose the particle is having the energy E, where E is lesser than the height of the barrier. There is no necessity for the particle to come back. There is some probability for the particle to make its forward journey without reflection by the way of quantum tunneling. What is null operator? If an operator A operates on a function and reduces the function to 0, then the operator is called a null operator. Here A is an operator which is operating on the function f of x. A with a cap represents an operator. It is operating on f of x and the result is 0. Then a cap is called a null operator. This is our null operator. What are the conditions we suggest for a one-dimensional box to have a particle? The walls of the box are rigid, hard and elastic. The potential energy of the particle when it is inside the box is V of x equal to 0. The necessary condition is x greater than or equal to 0, less than or equal to L, the width of the box. Give the energy expression of the particle in a one-dimensional box of width L. E equal to n square pi square h cross square divided by 2 ml square, or E equal to n square h square divided by 8 ml square. Both are same because h cross equal to h pi 2 pi. If you replace h cross square by h square divided by 4 pi square, we can get this relation. The quantum number 0 and negative cannot exist in the particle in a box problem. Why? Here the value of n not equal to 0 and we are taking the positive quantity alone. 1, 2, 3 and so on. We won't consider minus 1, minus 2 and minus 3. What's the reason? If n is equal to 0, the kinetic energy of the particle is 0. If kinetic energy is 0, the particle is always at rest and is unacceptable. For k equal to 0, the wave function is also 0. Here k stands for the momentum. Momentum is 0, the wave function is also 0, and then the probability of finding the particle inside the box is also 0. The negative values of n, simply repeat the corresponding values for positive n and do not give an independent solution. Both are same. See the 16th question. The 16th question, in the particle in a box problem, differentiate the classical and quantum results. According to classical consideration, a particle in a box can have any value of energy from 0 to infinity, but in the quantum approach, energy is quantized. According to quantum mechanics, a particle should have a minimum amount of energy and not 0, but the classical view accepts the 0 value. Classically, the particle is equally likely to be found at any point within the box from 0 to L, But according to quantum mechanics, the probability of finding the particle is maximum at the antinodes and the minimum at the nodes. Now, what are nodes and antinodes? We have to discuss. What are the nodes and antinodes? In terms of probability density, an antinode is a point of maximum probability density, and a node is a point of minimum probability density. Give the momentum value of a particle in a one-dimensional box. Pn equal to n h by 2l is the value of momentum. So here, for a free particle, E equal to p square by 2m. Here the value of E equal to n square pi square h cross square divided by 2m l square. This is equal to p square by 2m. Then n square pi square h cross square divided by l square is equal to p square. Now we may write this is equal to n square pi square h square divided by 4 pi square l square. This pi square cancelled out, and p square is equal to n square h square divided by 2l square. Then p equal to nh divided by 2m. The momentum of a particle inside the box is directly proportional to the natural number n and inversely proportional to the width of the box L, but independent of the mass of the box, mass of the particle. Mass of the particle. Suggest an eigenfunction for a particle in a one-dimensional box. Psi of x equal to a sin kx is the eigenfunction. Here a is the normalization constant and its value is root of 2 divided by L. Here L is the width of the box. Then k equal to n pi by L because k equal to n pi. Differentiate between potential step and potential barrier. A potential step corresponding to the force field acting on a particle being zero everywhere except in a limited region. However, the potential barrier has two steps. The distance between the two steps is known as the width of the barrier. See, this is potential step. This is potential barrier. The distance between these two regions is called barrier width. What do you mean by transmission coefficient? The transmission coefficient is a measure of the probability that the incident particle will be transmitted across the potential step. What do you mean by reflection coefficient? The reflection coefficient is a measure of the probability that the incident particle will be reflected by the barrier. See this question. A proton and a neutron having the same energy penetrate a potential barrier of height V0. Which particle can have a greater depth of penetration? Depth of penetration is given by the formula delta x equal to h cross divided by 2m into V0 minus c inside the root. We know that the mass of the deuteron is greater than the mass of the proton. H11 is our proton, H12 is our deuteron. Here the mass of the deuteron is greater than the mass of the proton. So therefore the proton has a greater depth of penetration because for the deuteron the value of mass is greater. So delta x is lesser. For the proton the m value is low. Therefore delta x is high. Then we can say proton has a greater depth of penetration. why do we use the reduced mass of the electron instead of its real mass when solving the hydrogen atom problem? We assume that just the electron is orbiting the nucleus and the nucleus is stationary. Actually, the nucleus and the electron both revolve around their common center of mass. Because the mass of the nucleus is greater than that of the electron, the common center of mass is relatively near to the nucleus. Such a two-body problem is equally valid as one-body issue. Therefore, use the reduced mass. What is the potential energy of the electron in a hydrogen atom? The potential is Coulombic type. Then the value of V of R is minus ZE square divided by R, or we may say minus ZE square divided by 4 pi epsilon naught into R. Here the potential is spherically symmetric as well as Coulombic. Why do we express Schrodinger's equation for the hydrogen atom in spherical polar coordinates? Rather than expressing the equation in Cartesian coordinates, we are expressing the Schrodinger equation in terms of r theta pi. What is the reason? The spherically symmetric potential of the hydrogen atom needs spherical polar coordinates. Suppose the potential is spherically symmetric, it is a function of r only. As the coordinates r theta and pi are orthogonal to each other, as the coordinates r theta and pi are orthogonal to each other, the Schrodinger time independent wave equation of hydrogen atom is expressed with a wave function consisting of the product of these three independent variables. What's the range of r theta and pi in spherical polar coordinates? Range of r is 0 to infinity. Range of theta is 0 to pi. Range of pi is 0 to 2 pi. State azimuthal component of Schrodinger's wave equation of hydrogen atom. Pi equal to a e power plus or minus im pi is the value of azimuthal component. Here the value of a is 1 divided by 2 pi inside the root. We evaluated this using the normalization condition. M is equal to 0 plus or minus 1 plus or minus 2 and so on. Give the theta equation of the hydrogen atom. Theta of theta equal to BPLM of cos theta. Here the constant B value is this much and PLM of cos theta. Give the radial equation of the hydrogen atom. Rnl of R equal to e power minus rho by 2 rho power L C into Laguerre polynomial. The value of C is this much. What's the energy eigenvalue of hydrogen atom? E equal to minus mu z square e power 4 divided by 2 m square h cross square is the energy eigenvalue. Give the degenerate eigenstate of the hydrogen atom for n is equal to 2. For n is equal to 2, the possible orbital angular momentum quantum numbers are 0 and 1. For L equal to 0, the value of m is equal to 0. For L is equal to 1, the possible m values are minus 1, 0, plus 1, because m can have minus L to plus L values. Then psi NLM is the eigenstate. Here n is 2. In all the cases, the value of n is equal to 2. Suppose L is equal to 0, the value of m is equal to 0. So psi 2, 0, 0 is one possibility. Suppose L is equal to 1, we can get three possible values. So psi 2, 1, 0, psi 2, 1, minus 1, psi 2, 1, 1. For the given value of n, the degeneracy is n square, that is fourfold. Give the ground state eigenfunction of the hydrogen atom. Psi 1, 0, 0 equal to 1 divided by pi a0 cube inside the root e power minus r by a0. We are given all other eigenstate in the complete video. If you are really interested, go and capture it. What are spherical harmonics? The product of the functions pi m and theta lm is known as spherical harmonics. It is denoted by ylm of theta comma pi. Ylm of theta comma pi equal to the value of pi is a e power im pi into this theta equation bplm of cos theta. The principal quantum number n cannot be 0. Why? If n is equal to 0, consider this energy expression. If you put n is equal to 0 here, the energy is infinity. It is not possible. Furthermore, if n is equal to 0, the radius of the orbit is also 0. It means that the electron is inside the nucleus, which is impossible. Define the degeneracy of a system. Degeneracy of a system is defined as multiple eigenfunctions corresponding to a single energy level. Here we have specified two eigenfunctions, psi1 and psi2. Both eigenfunctions are having the same energy level E. Now we may say the system is in the state of degeneracy. If it is in a non-degenerate state, you can write E1 psi1, E2 psi2. This is non-degenerate state. What's a rigid rotator? A system consisting of two spherical bodies attached together in a fixed distance and capable of rotating about an axis, passing through the center of mass of the system, is called a rigid rotator. Give the energy eigenvalue of a rigid rotator. E equal to L into L plus 1 h cross square divided by 2I is the energy eigenvalue. If you put L is equal to 1, E1 is equal to 2 h cross square by 2I. If you put L is equal to 2, E2 equal to 6 h cross square by 2I. If L is equal to 3, E3 equal to 12 h cross square divided by 2I. In the case of rigid rotator, the energy levels are unequally spaced. What's the energy eigenfunction of a rigid rotator? Psi of theta comma pi equal to theta of theta into pi of pi. This is the pi of pi value, a e power I m pi. The theta of theta, theta equation is b plm of cos theta. The value of a is 1 divided by 2 pi inside the root. Then we have presented this e power I m pi as such, which is having plus or minus sign. Then the value of b is this much, then plm of cos theta. This is a wave function of rigid rotator. It's all about things existing in this unit. If you want to learn more, it's better for you go through the core videos which I have presented. Thank you.